We would like to take you through a basic tour of RealityServer for Onshape, a cloud-based, GPU-accelerated, photorealistic rendering solution that's been fully integrated right into Onshape. Like Onshape, RealityServer does all of its processing in the cloud. Instead of struggling to render images with the CPU on your client device, RealityServer renders Onshape models remotely, using powerful graphics cloud servers that then delivers great, physically accurate images on your models straight back into your browser in real time. So here, with our Onshape document already loaded within our browser, we can click on the Plus tab to add the RealityServer app to our document file. But if the RealityServer app does not appear in the application list, it means you have not yet created your RealityServer account. To do this, you just need to click on the Go to App Store tab. And under the rendering category, you should see the RealityServer app listed, or you can just search for RealityServer. To use RealityServer, you need to be subscribed to one of the listed plans. But if you're only starting out, we suggest you select the free option, which will provide you with 2 free rendering service hours per month. When you click the plus icon again, under Add Application, you will now find RealityServer listed, which you click on to add a RealityServer tab within your Onshape document. The RealityServer dashboard then opens within our new tab. So let's take a minute to look at what we have here. You'll see some basic instructions to get you going in just a few steps. But before you start any sessions here, you can click on the Server Status button to check out the list of the currently available servers. Back to the dashboard page. The most important item here is the big power button at the top. This turns your RealityServer on and off. When we say your RealityServer, that is exactly what we mean. While using RealityServer, you have dedicated access to a high-end NVIDIA GPU instance. The power button will let you start and stop your server, and while the power is on, your allocated GPU hours are being consumed. But to help minimize any wasted server time, if no changes or tasks are detected for a period of 5 minutes, your server will automatically turn itself off, just in case you forgot to do so yourself. Here you have details on how much rendering time you have left, and how much you have used so far in the current session. Now let's turn on our RealityServer and start rendering something. Preparing your server usually takes around 15 to 40 seconds. Currently we're using NVIDIA Tesla M40 GPUs for all users, which has 24 GB of onboard memory available, so almost any model you can load in Onshape should happily render in RealityServer. Once the server is running, you will see a list of your previously saved RealityServer scenes for the document you're in. If you haven't made any scenes yet, as in the case here, you can simply press the Create button to get started. A selection dialog will pop up where you can select which part, studio, or assembly from your document that you want to render. Next, you can customize the tessellation settings, if needed. This will control how smooth the mesh will be in RealityServer. For most cases, the default settings is all you'll need, but there are also presets for coarse, medium, and fine tessellation, though if you really want to control the model mesh in detail, you can specify these in the custom settings. Once done, press the Start button to begin the conversion. The button will change to show you the stage of the process that you're in. After which the RealityServer interface will load with your model displayed in the viewport. The image you are seeing now is rendering live on your GPU server and is fully interactive. Before diving into some of the features, let's run through the various toolbar items we see here. Render mode, where you can use either iRay Photoreal for a fully physical accurate image stream, or iRay Interactive that uses advanced approximation algorithms to mimic realism for a faster image stream. Save. You can save your scene at any time so you can come back to it later on and continue editing. These width and height numbers are the current viewport size measured in pixels. Since the live view is fully interactive, you can simply click and drag with your mouse to orbit around your model. Holding down Shift and dragging, you can zoom in and out. Control or Command on a Mac to pan, and Control and Shift or Command and Shift on a Mac to look around instead of orbiting. Double-clicking on any part of our object will change the camera orbit point to where we clicked, so we can orbit around and zoom into or out of that area of the model. Next, we will click on the seat cushion to bring up its selection and material attribute detail, and use this to show you the key sections of this user interface by clicking on the Help icon. The first highlight is the Scene Graph section, which provides you with ability to individually select or control the visibility of any individual or multiple elements of your model, including cameras. Next is the Materials library, which contains all of the predefined MDL materials that can be assigned, edited, or combined to create your own custom materials. And within this same section, you can also access the Environments library to provide realistic illumination of your scene and, as an option, provide a 360-degree background image for your model. In this section, after you've selected any element in your model, you can either edit its inbuilt attributes or add new ones. Within the same section, you can also simply edit your selected object material parameters or drag additional functions onto compatible parameters to build up more complex material definitions. Next is the Toolbar section, which contains the Scene Camera, File, and Navigation functions. Then we have the Exit button to close the editor page and return us to our RealityServer dashboard. Now we click the Create Camera icon to save the current view as a new camera. And note that our new camera is added in the Scene Graph list. Then we click the Ground Shadows and Background icon. In this dialog, we can control the background color, which is currently set as white, but you can change this to any color you wish or even remove the background color to expose your selected surrounding environment. To show our model sitting on a realistic floor plane, we check the Ground Enabled option, which will work correctly if the base of our model is precisely set on the XY plane. If not, we can click on the Auto button to set this ground plane at the lowest point of the model, or alternatively, enter your own values to set a custom ground plane height. If you're using one of the physically correct Skydome environments, you can use the Location and Time dialog to precisely set your scene location and time of day for accurate daylight rendering of your context scenes. More on this feature later in the movie. Next, we check out the Render to Disk option, where we can choose to either render and save our image to disk, or we can save it back into our Onshape document as a separate image tab. Clicking on this icon will expand the image view to full window size, and clicking this icon again will return us back to the default view. Returning to the Scene Graph section and clicking on the Options tab will display a list of rendering parameters that either have been enabled and set, or others that are available and not yet enabled. For example, if we open up the AI denoiser option, we can enable this function by clicking on and creating the added parameters for Available to Use, Enabled, and Start Iteration. Then, if we check the first two checkboxes, accept the default start iteration number, and force a re-render of the scene, you will notice how the AI denoiser function removes image noise much faster and displays a fully converged image within just a few seconds. Another useful parameter set can be found by selecting any of your cameras, which allows you to control a large range of settings for each individual camera that you have been adding to your model scene. Now, you can see the materials throughout our model are pretty flat and lifeless at the moment. All Onshape derived finishes comprise of only simple color and opacity parameters, which at this point is the only information that our rendering system has to work with, hence the unrealistic appearance. So the key to great renders are the material assignments, and here we will use the inbuilt material library to quickly make our model look far more realistic and interesting. The inbuilt material library comprises more than 1,400 high quality and ready to go materials from the NVIDIA vMaterials MDL library, with a large range of high quality materials in each of the AEC and design folders. We will start by opening up the master assembly in the Scene Graph section and select our bowl, which becomes highlighted with a yellow outline in the rendering viewport. Next, we will move the camera for a closer view and create a new camera at this position. We'll call it View 2. and now appears in the camera drop-down list. Now we move back to the previous camera position and start working our way through the inbuilt material library system that comprises a very large number of pre-configured real-world material definitions. We can slowly drill our way down through the wide variety of categories to find the material we want to use. Or, alternatively, we can use the search function to take us straight to the material type we're looking for. In this case, we're searching for a suitable plastic material, and when we enter this into the search field, we have a choice of 97 plastic materials to choose from. So we select PCB blue and use one of the two methods available for assigning materials by dragging this selection onto our bolt geometry, where the material type changes within seconds. Next, we search for wood materials, which provide us with a selection of 123 different timber finishes. This time, instead of using the scene graph to select our objects, while holding down the Control key, or Command on a Mac, we simply click on the objects in the rendering viewport that we want to drop our selected timber finish onto. We choose Laminate, Birch, Natural as our selected finish, and instead of dragging this material onto these objects, we use the right click or context menu and click on the Assign to Selection option to apply this finish to those objects. Next, we click on the floor section and choose the Maple, Chevron, Rustic timber finish using the Assign to Selection option. Now this time we want to reduce the size of the planks in this material, and we do this by selecting the Materials tab in the right hand section of the UI, which brings up all the material parameters of our selected floor surface. Then going to the Transform subsection, we change the X and Y scale parameters from 1 to 0.5, which reduces the plank size by half. Next, we search for a suitable glass material to apply to our bowl, which provides us with a choice of 26 different glass types to select from. We reselect our bowl and choose Glass Clear, using the Assign to Selection option to apply this material to the bowl geometry. Now we select the top section of the side table, and while we still have the glass materials displayed, we assign Glass Privacy. Next, while holding down the Control key or Command on the Mac, we click on the handrail plus the back panel sections and the two drawers as our next selection. We search for paint materials, scrolling through the resulting list until we find Paint Metallic Gel Coat Red, and assign this to our selection of objects. We can see how these few and simple material assignments are already turning our flat-looking CAD model into something much more interesting and realistic. Next, we select the body of the side cabinet and the horizontal strip sections, then assign Paint Semi-Gloss White from our paint material list for these parts. Selecting the light fitting body and the light switch back plate, we search for metal finishes and select metal brushed for these parts. Now for the seat cushions and throw pillows, we start by searching for suitable fabric materials. Then we click on the seat cushion section and assign denim dark blue. Next, we click on the throw pillow and scroll back further down through the fabric material list until we find and assign flannel red and black. By now you should have a pretty good idea of how to assign materials and edit basic material parameters. So to save time here, we'll jump to the end of the material assignment bit. The big difference you'll see here is that we've assigned light emissive materials to various parts of our model, which is exactly the same process as you've seen previously, where you can adjust the material parameters to control both the quantity and color of the light that is being emitted. From there, the physically accurate light transport rendering engine built into RealityServer always ensures high quality and photorealistic results. Now moving the camera to a close-up view of the top of the side table, we want to show you how certain material definitions can be combined to produce custom material finishes. First, we select the glass top section, which we previously assigned with glass privacy from the inbuilt vMaterials library, and then you can see the listed material parameters in the right-hand section of the user interface. Now we will drag and drop the 3D checker texture onto the coat parameter of the material definition as shown here. First, you'll see the selected tabletop surface changes to a checkerboard pattern of alternating glass privacy and clear glass squares, which you can further edit in the material parameter section to change the pattern size or insert other material definitions. Moving back to our original camera position, we will now take a closer look at the environments section. Environments are made up of spherical high dynamic range or HDR images where the varying brightness value of each image pixel is used to accurately illuminate your 3D model at the center. As we scroll down through the thumbnail images, you can see that the inbuilt library contains more than 100 different image environments to choose from. To make it a little easier to find the right environment for your model, you can click on the library list on the left-hand side to open up a subcategory list. We'll start by checking out the physically accurate daylight category, which contains the two measured sky systems most commonly used for accurate sun-sky rendering and daylight studies. So we select the Pretham Sky Dome and simply drag this onto the background section of our viewport and watch the change in the illumination of our model. Now because we've chosen to light our scene with a physically correct environment, we can use the location and time dialog to set a precise location and time of day to view the exact appearance and shadow detail of our model scene. We change the time from 1:35 PM to 9:35 AM and view the result. Next, we scroll further down the list to see the wide variety of environment subcategories that are available to us. Selecting the indoor category, we're presented with quite a large list of environment thumbnails. We start by clicking and dragging the Blender Institute environment into our background and view the change in appearance. This environment now makes the scene look much warmer and brighter. To adjust this, we can click on the Options tab in the Scene Graph section to bring up the available environment attributes in the right-hand section. There we will find the intensity field and reduce the value from 100,000 down to 10,000 and watch the scene become much darker. Scrolling up and down the available attribute list, you can see other attribute values that can be edited to adjust the appearance of your model scene. Now we click and drag the bathroom environment into our background, which we had previously found to give us the best combination of lighting and shadows for our model. This would be a good time to save our document file with all this updated detail. Within the user interface here, we're viewing a streaming image of our scene at a resolution of 1005 by 508 pixels. But we can use RealityServer to create and store much higher resolution images, using the render to disk option as shown here, which can be stored either as a separate file on your local disk or a network drive. Alternatively is to have this image stored as an additional tab in your Onshape document file, for providing quick access and sharing with other users of this document. The dialog for either option is very similar, where on the right hand side you can choose the quality detail from a simple drop down menu or select custom to enter your own values. On the left hand side you can set your image aspect ratio, frame size and your saved image file format. When you're finished with the image settings as shown here, you just need to press the render button to have the remote server cloud graphics engine render your image. Depending on the settings you have selected, this process could take a few minutes to complete. At the end of the rendering process for the image to disk option, you'll be asked to confirm or change the image file name and location where you want the file to be stored. Before we end our RealityServer session, we should save our document one more time. And now we click the Return to Dashboard button. We were asked to save again, but we've already done this, so we click the No button. Here we will briefly return to the RealityServer login page. But then within seconds, we're automatically taken back to the Save Scenes page, where we can reopen the scene we were just working on, or we could create other additional scenes with different configurations of material assignments and lighting environments. But if we've finished editing our scenes, we just need to click on the power button to end our RealityServer session and return to the RealityServer login page. So, with the combined power of Onshape to produce highly detailed and accurate engineering models and RealityServer's ability to assign physically accurate materials and lighting environments in real time, all without the need for any high-end local hardware, users can readily create studio quality photographic images of their own product designs that will turn their work from flat-looking CAD drawings into valuable and real-world communication content. This is where your work could go from this to this. Well, that concludes our tutorial of the main features and functions of the RealityServer plugin. But there is much more depth and capability in many of these functions that we have not been able to cover in this video. So we do encourage you to use the free trial account and explore for yourselves how RealityServer could transform your design and process outcomes. If you need any assistance with RealityServer, you can reach out to us using the help features within Onshape, or directly via our website at www.migenius.com, where you can also find out more about our other products and services. Happy rendering!